Let's talk about the greatest common factor. It's also known as a GCF. Now, sometimes in some math textbooks and in different applications, you'll see greatest common divisor, which of course would make this a GCD. I'm going to stick with GCF, but GCD is the same idea. So we often look at greatest common factor, greatest common divisor, and we say, oh, greatest, it must be a big number. Actually, the opposite is true. It's the greatest thing, it's the largest thing that will divide into both numbers without a decimal. That's what it really is. But because it divides into both numbers, sometimes it's kind of small. So let me kind of walk you through one and you'll see what I mean. But I think the key word in greatest common factor isn't so much greatest as it is the word common. It's what they share. So what do I have that this person also has, and that's what we have in common. And I'm going to take the most things that we have in common. So let's start with just a really basic example. And I'm going to find the greatest common factor, and here's the directions. Find the greatest common factor. I would say between. I used to word it like that, but then people think it's between the two numbers, and that's not necessarily the case. Find the greatest common factor of, so here we're going to do several problems, and those are our directions. So the first one's going to be 15 and 20. Okay, maybe you know the answer off the top of your head. And that's actually where I'd like for us to go with this. Eventually, I'd like for us to look at that and say, the answer is, I'm not going to tell you the answer. Maybe you know it, maybe you don't. But we need to learn to stare at that and just have the number sense to just say it. That's why this unit is called number sense. But if we can't, that's okay. So let's find two numbers that multiply to give me 15. And I'm not going to go through the big process we did in the previous lesson. Let's just do this. So 15 is really 3 prime times 5 prime. Okay, 3 5s give me 15. 20 is really 4 times 5. Well, 5 is prime, and 4 is not. If you were ahead of me, you're saying, oh, they have 5 in common. I hear you. You're right. We're going to get there. But sometimes we need to finish the whole process before we really identify it. You'll see one like that in a minute. So 4 is really 2 times 2. Okay, so here's the deal. We have factored 15, and we have factored 20. Now, I'm not going to write 3 times 5 and 2 squared times 5. I'm not going to. It really doesn't help me with this process. But what I am going to do is just kind of draw a squiggly line in between them. And I'm going to look at these two sides, and I'm going to say, what does this one have? What prime numbers have I circled here that I also circled here? And the answer is 5. And it's kind of obvious. I mean, it's here, it's here. So in this case, the greatest common factor is 5. And when I say is, I'm going to put equals. Okay? So the greatest common factor is 5. So let me kind of demonstrate that a little bit. I'm going to grab a calculator. Knowing that it's a factor, then it is what goes into this and will not give me a decimal if I divide it out. Also, it's the biggest thing I can divide into 15 and also divide into 20 and it not give me a decimal. So let me grab a calculator and I'm going to show you. So what I really have here is 15 divided by 5. No, oh, great, no decimal. 20 divided by 5. Oh, great, no decimal. If I try to divide something bigger, I get a decimal out of both of them. Or maybe I'll get a decimal out of one of them. For example, I could divide 20 by 10, and that works. Not a decimal out of this one. But if I divide 15 by 10, then, oh, I do get a decimal. So, I need to be cautious because I need the biggest thing that will go into both of them, but it's got to go into both of them without a decimal. And so when we say greatest, notice that 5 is significantly less than 15 and significantly less than 20, but that's the biggest thing that I could divide out of both. I'm going to erase this example, and we're going to do another one that may not be as obvious, because maybe you saw the 15 and the 20 and you're like, it's 5. Come on, don't be lame. Let's do this one. It's going to be 12 and 18. And maybe you know this one off the top of your head. All right, that's great if you do, but I'm going to keep going. So let's say that 12 is 3 times 4. 3 is prime. 4 is 2 times 2. So we factored that one. I'm not going to waste your time with a previous lesson. 18 is, let's see, we have a couple options. We could do 3 prime times 6. We could also do 2 times 9. Either one, you're going to get the same thing over here. We're not finished because 6 is not prime. So 2 times 3. Okay, so this one is a little bit different because if I was going to look at you and say, okay, what's the greatest common factor? What do they have in common? You would say they have 3 in common. Oh, they have a 2 in common. When there's a 3 and there's another 2 and there's a, wait, and it gets confusing. It can really be confusing trying to identify what they have in common. The previous example, you had a 5, you had a 5, we're done. But now we have a 3 and a 2 and a 2 and a 3 and a 2 and a 3 and, okay, let's go slowly and let's identify what they have in common. And when we do, we'll mark it out. So my greatest common factor is what goes into this that also goes into this. So if I see something circled here, I'll find it over here if I can, and then I'll mark them both off. So, okay, 3. This one has a 3, and this one has a 3. So let's put a 3. Don't put 2 3s, because it's what they have in common. So I'm saying, oh, you have a 3, you have a 3. Let's put a 3 because you have it in common. All right, what else? Oh, this one has a 2, and this one has a 2. So I'm going to put a 2, and let's multiply them for reasons that I'd love to explain, but I'm not at the moment. And then I keep looking. Do they have anything else in common? Well, there's a 2 and there's a 3. So no. No, these aren't the same, so no. So the greatest common factor is 6, which means 6 goes into 12, 6 goes into 18. And that's the greatest thing. That's the biggest thing that divides into both of them. That's what the word factor means. It divides into it. And they have that in common. So it's the greatest common factor. Let's do a couple more. I'm going to make bigger numbers. By a couple, I mean like 3. So let's do 175. Okay, I'm going to factor kind of quickly. The hard part, I think, is getting down here in the weeds and finding what they have in common. So 100 is 2 times 50, 20 times 5, 10 times 10. I'm going to go with 10 times 10. Neither of those is prime, so 2 times 5. 2 times 5, there we go. 75 is not very obvious, actually. If I was going to give you $75, I would give you all of it in 5s, but I'd give you 15 of them. If I was going to give you 75 cents, I might give you 3/4. I might give you a 3 times 25. Same thing. 15 is 3 times 5. Okay, so we factored. That might take a little bit more time individually, and that's okay. But the greatest common factor is what I see over here that I also see over here. And if I see something here and I see it here, I'm going to mark both of them out and I'm going to put it down here once. Okay? So let's look. I see a 2. Do I see a 2 over here? No. Sorry, but I don't. I see a 5. Do I see a 5 over here? Well, I see 2 of them. Don't get carried away now. Don't be like, oh, there's one, there's one, there's one. Ah, okay. I see one. I see another one. I saw a pair of 5s. There's a 5. Okay, let's keep going. I see a 2. There are no 2s. I see a 5. I see another 5. The greatest common factor is 5 times 5, which of course is 25. If I have $100 and you have 75, and I say, well, I wonder if we can split our money evenly. What kind of numbers can we divide it into? Somebody's going to say, well, you could do 4 25s and you could do 3 25s and we'd still have groups of 25. That's the biggest thing we could do if we're going to clump it together like that. Let's do a couple more. I'm going to end on a really strange one. So let's do one like this. What should I do? Put a 1 here. Let's make it interesting. Let's go 210. And let's go 49. Okay. I'm going to try to factor these without a calculator. I'm going to do the easy one first, okay? 49 is 7 times 7. Right? 210. Oh, goodness, I don't know. Yeah, actually, you do know. You kind of know already because it ends in a 0. It must be divisible by 10. Like if I'm going to give you $210, I can give it to you in tens. Like I could give you, what's this? 21 tens. So 21 times 10. That's not prime. That's not prime. It's not on this list. 21 is 3 times 7. 10 is 2 times 5. All those are prime. We come down here, we'll find our greatest common factor. Greatest common factor. I have a 3. Do I see a 3 over here? I do not see it at all. I will not write a 3. No, I won't. And a 7. I see a 7 here, and I see a 7 there, and I really do not care because I only want a pair. Okay, I did not intend on that rhyming like it did. I was flowing. Should have kept going. 7 and 7. 7. Okay, what about him? Who cares? This guy, he doesn't have another friend over here. Sorry, but he doesn't. 2, nope, no 2s. 5, nope, no 5s. GCF is 7. Okay, I'm going to do one more. Actually, I just realized I need to do 2 more. Can I? Please, please. I think I will. Let's actually do the same problem again, but not the same problem again. Let's do 7 and 49. We just did this one, and it's 7 times 7. I'm going to do this one quickly because I promised only one more example. Now I'm doing 2. I'm sorry. 7 is already prime, so there's nothing to factor. So if I was going to come down here and talk about my GCF, then I would have 7, it's still 7, okay? So now let's do one more. And as I do this one more, I'm going to pick one that's just really odd and really bizarre. And I'm going to go kind of crazy on it, and I'm going to make it super easy. 2 and 7. What's the greatest common factor of 2 and 7? Okay, well, first of all, this one's prime, so I could circle it. And this one's prime, and I could circle it. And then I would get down here, and I'd say, well, what's the greatest common factor of 2 and 7? Well, they don't have anything in common. So the temptation would be to say, there is none, so I'd put 0. No. Okay, here's the deal. If I do that thing that I don't want to do, if I was to say, well, you know what, this is really 1 times 2, right? Now I'm going to start using 1 here. Sometimes I have to. That's 1 times 2. That's why I'm making this face. I don't want to use the 1, but I have to. 7 is really 1 times 7. I don't want to use that 1, but I have to. And now I look and I say, well, what do they have in common? The only thing that divides into 2 and 7 is 1. I mean, 1 goes into everything, right? So the GCF is 1. So sometimes, if they don't have anything in common, the greatest common factor is 1. Okay, I'm going to say that again. If they don't have anything that looks like they have in common, then they actually do. It's a 1. So when you're down here and you're like, oh, 2 and a 7, nothing matches, it's 1. If you get a big long thing, you got this thing and you end up with like 2, 2, 7, 19, and over here you have 5, 5, 13, and 37. You know what the greatest common factor is? 1. Nothing here is here. It's a 1. There you go. There are some greatest common factors.